Welcome back to the deep dive. So today we are strapping on our tool belts and diving straight into the technical bedrock of project setup. Specifically, we're going deep into the Haskell ecosystem.
That's absolutely right.
We've been handed a stack of sources that guide us on a mission for efficiency, bootstrapping a new app, our sources call it fish, and then instantly cleaning up the verbose mess that the default tools can leave behind.
Yeah, that's the key. For anyone starting a new Haskell project, the gateway is the cabal init command. It's essential.
Right.
It generates all the scaffolding. But as our sources really show, the configuration you get while it works is just incredibly cluttered.
So our mission for you today is what? To decode that.
Exactly. We're going to analyze that initial verbose output, understand the parts that really matter, and most importantly, find the shortcut that just strips away all that noise. We're going from dense boilerplate to, professional clarity in just a couple of steps.
Okay, let's unpack this. Let's start right at the foundation.
Yeah.
What does that initial setup actually give us?
So you run cabal init.
Right, interactively.
Yeah.
And you get this multi-layered file structure, which, looking at the directory tree in our sources, it actually seems pretty well partitioned right out of the box.
It is, and that logical separation is it's key to understanding modern Haskell development. You see three distinct functional areas.
Okay.
We have the app directory, which is for your main executable file, main.hs. That's the entry point.
The part the user interacts with.
Then you've got the src directory. That holds the core logic, so your library modules like mylib.hs.
So separation of concerns. The library is the engine. The executable is the UI that calls that engine.
Precisely. And the third zone is the test directory. It often has its own main.hs, designed just to run the test suite against the code in src.
A very standard, maintainable structure.
Exactly.
And then around those folders, you have the boilerplate, changelog.md, the license file, and of course, the heart of the whole thing, the fish.cabal file. Seems like it's all ready to go.
It seems like it. But our sources hint at a common oversight here. Well, this is where you, the learner, should pay attention. If you really look at that initial file list, something crucial is missing, something you would absolutely need before you push this to Git.
What is it?
The README.md file. Cabal init doesn't generate it.
Wait, really? Why would it give you a changelog and a license, but not the main documentation file?
It's probably a philosophical choice, The Cabal maintainers give you the mandatory legal and versioning files, but the main docs are so project-specific, they leave it up to you.
But in practice?
In practice, the first thing you do after you bootstrap is manually add that README.md. It's a small pitfall, but a common one. And we'll come back to how we tell the configuration about that new file later.
Okay, that is a critical takeaway right there. Tooling handles code, documentation is on you. So let's pivot to the center of it all, the fish.cabal file itself. Our sources describe the initial state as quite dense.
Oh, it's a huge wall of text.
Filled with wordy comments and oddly padded alignment. It sounds like a nightmare.
I remember just wasting so much time scrolling through that when I first started, trying to find one line I needed to change.
So why is it so verbose?
The source material explains it. When you run Cabal init, it asks you, add informative comments to each field in the Cabal file. And the default answer is yes.
Which is great if you're a total beginner, I guess.
Right. A tutorial inside your config.
But if you're focused on efficiency, it's just pure noise.
Complete noise.
So let's cut through it. What are the key metadata fields here? Right at the top, we see Cabal version, 3.14.
And this is a point of necessary technical nuance. As the sources point out, this number is the version of the .cabal specification itself.
Grammar of the file.
Exactly, not the version of the Cabal build tool you're running.
So if I set this too high, what happens? My build tool just complains.
It will fail instantly. If you set Cabal version higher than what your build tool's Cabal library supports, it just won't know how to parse the file. It's a really important backward compatibility check.
Got it. Specification version, not tool version. Okay, moving on. We get the package version, point 1.0.0. The source mentions the Haskell package versioning policy, the PVP. What's that all about?
The PVP is basically the community standard for how you increment version numbers. It's critical for dependency management.
How so?
The principle is simple. Non-breaking changes, like a mug fix, you bump a minor version. But the second you make a breaking change to your API, you must increment the major version number.
So it's a social contract.
It's a social contract that lets downstream users know that your update won't suddenly shatter their code.
That's a great explanation. Turns version numbers into communication. We also see the standard stuff. license, AGPL 3.00 or later, tied to license file, licensee, and a synopsis.
Right, a console tool for fishy stuff.
And we can't skip the language setting. Default language, GHC 2024.
Which is crucial. It defines the base language version, giving you access to all the modern features in that GHC release without causing headaches later on.
Okay, so let's look past the metadata to the actual components being built. The file defines 3, and they seem to share settings, which is smart.
Yes, and this brings us to the first bit of structural brilliance in the file. The common warnings stanza.
Stanza.
It's a simple but really powerful shortcut. It defines settings once, in this case GHC OS options, -wall, and then you can import those settings across the library, the executable, and the tests.
So for the learner, that's an immediate win. If I want to add -where later, I just change it in one spot, not 3.
Exactly. A single source of truth for your build options. It's just good configuration hygiene.
And what are those components?
First, the library stanza, which exposes mylib and sources files from SRT. Then the executable fish stanza, which uses main.hs from app. And finally, the test suite fish test.
And the test suite has this odd-sounding type, exit code Studio 1.0. What does that technical jargon actually mean for testing?
That's a great question. It sounds intimidating, but it's really simple. It means the test program runs, and the build system checks if it passed just by looking at the exit code.
0 for success, anything else is a failure.
You got it. And the Stadio part just means the test communicates its progress using standard output and error. It's the most basic way to run tests.
So it's a standard, simple way to integrate tests into the build.
Yes. It's reliable, no complex tooling needed. Now, about dependencies.
Right. They all depend on the base package. But the executable and the tests have this extra dependency that's confusing.
The dependency on fish.
Yeah, they both depend on fish.
Yeah.
Why does the executable need to depend on itself? Isn't it all one project?
This is a crucial concept. While it's one repository, Cabal sees the library and the executable as separate internal packages.
Okay.
The library component provides the core code. The executable fish component is just a wrapper that imports and uses functions from that library. So it has to list fish, the internal package name, as a dependency to access the code in circmylib.hs.
I see. It's not depending on itself. It's depending on the core library component that has the same name as the project.
Exactly. That clears it up for so many people.
Okay, that brings a lot of clarity. But let's go back to that pain point. Even with this understanding, scrolling through that huge commented file is just tedious.
It's tedious, and it's prone to manual errors. We need a way to get from the tutorial version to the production version fast.
And this brings us to the aha moment for the efficiency-focused learner.
Indeed. The ultimate shortcut is Cabal format. When you're just overwhelmed by that wall of text, this command is your relief button.
So what does running Cabal format actually deliver? Does it just delete the comments?
It does way more. The help text says it all. Reformat the .cabal file using the standard style. It strips the clutter, standardizes alignment, gets rid of all those extra blank lines.
It just enforces consistency.
Yeah, stylistic consistency.
That is massive. That command saves, 30 minutes of scrolling and deleting every time you start a project? That's the real efficiency game.
It truly is. If you look at the after version in our source material, the difference is night and day. It's immediately readable. The metadata is concise, the components flow logically, no conversational noise. That import warnings line now just looks clean and totally integrated.
It's like running Prettier or RuboCop, but on your configuration.
It functions exactly like a code formatter for your project config. But, and this is important, there's a crucial detail the source material highlights.
What's that?
When the author runs the command, they get a warning. Warning, this command is not a full formatter yet.
Okay. So an important limitation. It handles the big visual cleanup, the 80% solution, but it might still miss some minor details.
Exactly. It signals that while the tool is super powerful and solves the main headache of verbosity, we shouldn't rely on it for, perfect automated hygiene yet. It's a huge step forward for readability, but the tooling is still maturing.
Okay, so now we have a clean formatted file. Let's tie up that loose end we found at the start, the missing README.md.
Right.
We manually created it, but the project doesn't know about it.
And that's the definition of configuration hygiene. If you add a file that's essential for the package, the .cabal file has to list it.
Otherwise,
when you build a distribution archive, that vital readmark.md will be missing from the package.
So we need to find the field in our now clean config that says which non-code files to include.
That field is extra doc files. The default file only listed changelog.md. So to finish the setup correctly, we manually update that block to include our new file.
And this manual step is non-negotiable. Even Cabal format won't do this for us.
Precisely. The change is simple. We just update the stanza so both documents are listed under the extra doc files heading.
So it looks like extra doc files, then on new lines, changelog.md and readme.md.
That's it.
And with that one manual tweak, we have a fully bootstrapped, professionally configured Haskell project. The efficiency gain is so clear.
Absolutely.
Using Cabal init and then Cabal format just slashes the time you spend on boilerplate.
We've gone from a verbose, tutorial-filled file to a clean, standard layout that clearly defines the project's structure, dependencies, and all its required files. Knowing those two commands is the essence of effective engineering.
It really is. You spend less time reading comments and deleting line breaks, and more time actually writing your code in SRC.
Look, configuration files are the project's contract. Learning to manage them cleanly, like we've shown by removing the clutter and adding essential docs, is absolutely key to maintaining a code base that other people and your future self can actually understand.
Which raises an important question for you, the learner, to think about. Given that Cabal format still warns that it's not a full formatter yet, where does that limitation point us? Does the author, Ang, need to find an external, more robust formatter for perfect cleanup? Or should we expect the Cabal specification itself to integrate new features? You should mull over just how far automation can really take us in standardizing project architecture.